Welcome to the second installation of Organic Functional Group video tutorials. This video tutorial is going to focus on IUPAC Nomenclature. And so the functional groups that we'll be looking at are shown here on our handout. We're going to look at alcohols, aldehydes, ketones, carboxylic acids, and amides. Esters, I've decided they're under a separate tutorial. Okay, now the main thing about naming organic compounds is to recognize that there's really only a few rules, and if we can follow the pattern, we can do this very straightforward, right? So the first thing to keep in mind is the root is the longest continuous carbon chain that contains the functional group. So now that we've learned how to recognize our functional groups, that will help us find the longest continuous carbon chain. And then we will use the suffix for the functional group. We'll replace -ane right from the homologous series, and then we'll use the table below. So, for example, with carboxylic acids, we would use anoic acid. Esters will be anoate. Amides, animid, aldehydes, anal, ketones, anone, alcohols, anol. Now, there will be cases where alcohols will be present around higher ranking groups. So, all of these functional groups so far do have substituent names, but you're not responsible for them in our class, so I took them out. But you will see hydroxy occasionally, particularly with carboxylic acids. The sulfhydryl group is a thiol group. Biologists tend to call it sulfhydryl. We won't worry about naming any of these, but chemists think of them in terms of thiol, and biologists tend to think in terms of sulfhydryl. We will learn how to name amines, anamine, and amines are another one, particularly amino acids we'll see, so we need to know the substituent name. And then we've already learned how to name alkenes and alkynes and alkanes. And there's also a separate video tutorial on ethers that also goes with the esters. All right, so we can see how important it is to recognize our functional groups. And then we use our homologous series, right, the eth, meth, prop, bute type thing to get the parent name or the root. And then, of course, we're going to have to put a locator number to tell us where the functional group is. And remember, we always want to give the functional group the lowest possible number. If we are naming amines and we have a substituent coming off of the nitrogen, we will use N as the locator. And remember that functional groups on cycloalkanes do not need a locator number because they're always on carbon number 1. Alrighty. And then the prefix, if there was a prefix, right, that would be any substituents, and we always cite those alphabetically. Okay, alrighty, so there is the overall strategy. Now let's look at some examples where I've given you the structure and the name so we can see how this strategy works. Once we've studied the strategy, then we will practice it, practice applying it, all right? So, remembering that the names, we haven't talked about this part too much, right? So, cis and trans only applies if we have double bonds or rings, and even not every double bond or ring can be described as cis or trans. So, this will be a special case for some molecules, right? So, the suffix, right, that's the key part because that tells us about the functional group, right? And so we have to tell everybody where the functional group occurs. So it needs a locator number. Then we will have our parent. You could think of this linguistically as the root, right? And that's where the alk comes in, and this is our homologous series. All right, so that, oops. All right, so that's where we have meth, eth, right, prop, bute, all of that. Okay, if we have the prefix, right, this would be the branches. And so the branches would be at the beginning. And notice we always have to tell everybody where they are. Okay, and then if it applies, we would have stereochem with cis or trans. And for substituents, remember that we cite them alphabetically. Alrighty, so we have the basic pieces. Now let's look at some compounds and see how this works. Okay, we can get this all, oh good, it just fits. Great, okay. So I've circled the highest ranking functional group, right? So there's the carboxylic acid, and here is the suffix that tells us there's a carboxylic acid. All right, so we've circled the suffix with the highest ranking group. Now let's put a box around the parent carbon chain, what we refer to as the root, right? So we have a 3-carbon parent chain, and that gets described by prop, all right? And then the last bit, we would underline substituents. So we have a alcohol, a hydroxy group, so 2-hydroxy. So we can see where every atom of our compound has been described through the name. It's really a very elegant system. All right, so let's practice this together to make sure everybody understands. Right, so here in this case, we have an alkene functional group. And so there's the alkene, and we have to tell everybody where it is. In our previous example, maybe it was bugging you. Why didn't we tell everyone where the carboxylic acid is? Well, carboxylic acids have to be at the end of the chain. So everybody knows they're coming off of carbon 1, so we can omit it. But a double bond can occur anywhere in the chain. So we have to make sure to tell everybody where it is. And we see that we have a 6-carbon root. So there's our hex. And then there's one methyl branch right here that we underlined. And then for this particular example, this alkene can exist as cis-trans, and it's been shown in the trans form. Right? So the things in red are focusing on our functional group. Okay. So this one's really, I'm not sure what to circle here. It's all single bonds, right? So I circled the ring just for the heck of it, right? So there's our alkane. When we see ane at the end, we know that it's all carbon-carbon single bonds. The root or the parent is the longest continuous carbon chain, so that would be the cyclohex. And then we have a 3-carbon propyl group coming off as a branch. So once again, see how every atom and bond of our compound is described by the name. Alrighty, here we have a carbonyl. So we look around and we recognize there's R groups on each side. So this is a ketone. And, oops, I want to write this differently. Alrighty, so we're going to redo this. So this would be 2-butanone. Alright, so the anone tells us it's a ketone, and the 2 lets us know where the ketone occurs. And then the bute is right here. That shows us it's a 4-carbon chain. And then we have one methyl branch coming off. So 3-methyl. Okay. Alrighty, and we'll put a little dash there. Alright, so that one's all set up. And now we'll look at the next one. So here we have an alcohol and an amine group. It's important to learn that alcohols have higher priority than amines. So here is our alcohol suffix with the locator. It's a 4-carbon chain or root. So there's the bute. And, oh dear, this shouldn't be bromo. That should be ethyl. Okay, so now we can fix this, right? So then there's our ethyl branch, and there's our amine branch. So the amino group, the amine's coming off of carbon 4, and the ethyl branch is coming off of carbon 3. So once again, all of our substituents are taken care of, our carbon chain, and our functional group. Okay, last one. Here we go, there's the aldehyde, so we see that as the enal, a 5-carbon parent, that's described by pent. And then once again, a hydroxy group is subordinate, an alcohol group is subordinate to the aldehyde. So there's the 3-hydroxy. So now that we have seen how each aspect of the molecule is described by the name, let's go ahead and practice naming some organic compounds. Okay, whoops. So here we go. Get the next sheet in place. Here we are. And get it centered. Okay, so I reminded you of our overall naming strategy right at the top of each page. So if you get lost, just remember to connect, and eventually you should be able to see this in your mind and not need to have it written for you. Alrighty, right? So our first thing is we want to make sure we see our functional group, find the longest continuous carbon chain, and identify any branches. Okay, so the branches are the prefix. We name those first. We tell everybody where they are. 4-methyl. All right, now we bring in our root name. That's going to be that should be in blue. Pent. All right, and then our suffix would be enal. Okay, and with many of the carbonyl groups, not all of them, but aldehydes and carboxylic acids, everybody knows, right, it must be carbon number 1, right? So we don't have to put the number. Okay, let's move to our next example. We find we have an alkene, and we look at that and we notice that it has the stereochemistry of cis. We're going to number to give the longest continuous carbon chain with the double bond having the lowest possible number. 1, 2, 3, 4, 5, 6. And once again, we have one branch. So this would be cis 5-methyl. And then we have a 6-carbon chain, so that gets represented as hex. And oops, I forgot, but I got to tell everybody, right? But we have to put the locator in, 2-hex-2-ene. All right, so we have to let everybody know where the double bond occurs in the 6-carbon chain. All righty, practice makes perfect. So let's keep going. Here is our highest ranking functional group. On a ring, we know it's always going to get the 1 position. We're going to number our ring to give this ethyl branch here the lowest possible number. So we'll number counterclockwise. Okay, in this case, we weren't shown any wedges or dashes, so this could be cis or trans, but nobody told us. So we'll just go with what we have. And so we put the substituent, the branch first, 3-ethyl. And now we bring in our root, our parent, cyclo, hex, and then enol. And then once again, this must be carbon 1. so we don't have to worry. If you put the 1, I'm not going to mark you off. It's not a problem. It's just not needed, so don't expect to see it when you read things. Okay, now to mix things up a little bit, here's a condensed formula. So we scan and we recognize CHO. There's our aldehyde. So since we know we want our aldehyde to have the lowest possible number, we will number this chain beginning here. 1, 2. We see the parentheses. We recognize that's a branch. 3, 4, 5, 6. All right, so we have a 6-carbon chain that has an aldehyde on one end. So there's 1, 2, 3, 4, 5, 6. And so then we notice from the condensed formula that there is an ethyl branch coming off of carbon 3. So we'll add an ethyl branch right here. Now that we have the skeletal structure, we can go ahead and write the name. So we begin with the prefix, the branches, 3-ethyl, and we have a 6-carbon chain, so that's the hex, and it's an aldehyde, anal, right? And remembering that aldehydes are understood to always come off of the first carbon. Alrighty, let's forge ahead here. Alrighty, so now we see our double bond, and in this case, if we number left to right, 1, 2, 3. If we number right to left, 1, 2, 3. So we have a tie. When we have a tie, our tiebreaker is, for example, we have a, oh, but that wasn't the longest chain. I almost fooled myself, right? We have to find the longest continuous carbon chain, 1, 2, 3. But if we go this way, 1, 2, 3, 4. So we should number, it's not a tie, we should number left to right. So I put this one in here on purpose to remind you that when the molecules are drawn, they're not always going to give you the longest continuous carbon chain on a velvet pillow. You got to be able to look around and discern. This double bond, what's the stereochemistry? It's shown as trans. Then we have 1 branch, 5-methyl, and we have a 7-carbon chain. We got to tell everybody where the double bond is, so we put the 3, the locator, in. And then we would put the hept to let us know there's 7 carbons. And then we would put the ENE to let everybody know that it's a double bond at carbon 3. Alrighty. Okay, so we'll move on to F. Here we see our carbonyl, and so we see R groups on each side, so that's a ketone. So we focused our attention on the functional group, but when we go to number the carbon chain, right, it's the continuous carbon chain. So remember to begin the chain, we're going to number right to left because we want to give the ketone the lowest possible number, and that leaves us with 1 branch. So 5-methyl, and now we need to tell everybody where the ketone is, so we put in a locator, right? So, for example, aldehydes have to be at the end of the chain, but ketones can be in the middle of the chain, so we have to tell everybody. It's a 7-carbon chain, so there's the hept, and now we bring in the suffix, unknown, right? Telling everybody where the carbonyl group is. Okay, so the last 2 on this page, notice here we have a ring and we see a wedge and a dash. So this is an example of a trans cyclopentane. We look at the substituents. We have a methyl and we have a propyl. So since there are no other high-ranking functional groups, this is a saturated hydrocarbon, M and P, we cite alphabetically. There's really no tiebreakers other than the alphabet. So we would give the methyl group the 1 position because M comes before P in the alphabet. And then we're going to number the chain, the ring, to give the propyl group the lowest possible number. So now it would be trans 1 methyl and then 3 propyl cyclopentane. Oops, and I guess we put the ANE. So that is the suffix ANE showing, and it's important because it tells us there aren't any double bonds or functional groups, triple bonds. Okay, now let's look here at this next one. Here's our carbonyl group. So we look around and we recognize that it's an amide. So we're going to find the longest continuous carbon chain that includes the carbonyl carbon of the amide. That leaves us with 2 branches. So just like we would with amines, if we have a branch coming off of the nitrogen, we can't use a locator number. Those are for carbons. So the prefix here would be N, 2 dimethyl. So one of the methyls is off the nitrogen and one of the methyls is off of carbon 2. And then we would bring in, it's a 4-carbon chain. There's our bute. And then the suffix for amides, animide. Okay, so there we go. Now, nomenclature is a topic that students find very challenging. So we're going to do another set of practice problems to make sure that you feel really strong and ready to do your homework. You can go ahead and give your homework a try now if you want, and if you get stuck, come back for more help, or just keep going with the examples that I have for you. Okay, so here's our buddy CHO again, the aldehyde, and 1, 2, 3, 4, 5. Recognizing here we have a small branch coming off of carbon 3. All right, so before we try to name this, let's make sure we have the structure correct. So there's our aldehyde coming off of carbon 1, 2, 3, 4, 5. And we have the methyl branch coming off of carbon 3. So this would be 3 methyl, 5-carbon chain, pent, and now. There we go. Okay. And now we'll go on to the next one. We'll scan our condensed formula, and we spot the amine again, recognizing it's coming off right here from this carbon. All right, so let's go ahead and create the hydrocarbon skeleton before we try to name it. So here's this first carbon, this methyl group, and then we go here, and I'm going to draw it like that. So the first carbon, the second carbon, the third carbon. We recognize the third carbon has the amine coming off. And now we have another CH2 group, and then we have a CH. And notice this CH group has CH2CH3. Okay, so I want to circle that. So this looks like it should be a branch, but let's keep going. And then we have the last methyl group. All right, so whoever did this condensed formula was I don't know if they were trying to trick us or what, but let's look at this. Notice that the longest continuous carbon chain is right here. So this is actually not a branch. This is going to be the methyl branch. That's why it's really important. This example is here to remind you to not try to name off of the condensed formula. Draw out the structure so that you give yourself a chance. So the correct name for this compound, I think I'll draw it up here in the space above, is we have a 5-methyl. And then we see that our longest continuous carbon chain is a 7-carbon chain. And we have an amine coming off of carbon 3. So we would put a 3 there, and then we would put our hept to recognize the 7 carbons, and then an amine. All right, there we go. Okay, so let's keep working our way through these other examples so that we're experts at nomenclature. The carboxylic acid is the highest ranking group, and notice in this case it has a hydroxy substitution. We have a 3-carbon chain. So the hydroxy group is coming off of carbon 2, 2-hydroxy. We have a 3-carbon chain, prop, and then for carboxylic acids, anoic acid. All right, so that's the name for K. Here we're back to a hydrocarbon, just a little stroll down memory lane. Remember that as we look for the longest continuous carbon chain, we want to put the first branch at the lowest possible number. So we can see that we have, there's a branch here, here, and here. So this branch is the closest to the end, so we're going to number this chain in this fashion. And now our substituents are all methyl groups, so we would be 2, 4, 5 trimethyl, and then that would be heptane, right? Because we have all single bonds. Alrighty, a few more to make sure that everyone does well. Nomenclature is very important because it helps build your ability to look at the molecules so that when we talk about their reactions and their biochemistry, you know where to look. So it's a very important foundational skill. Alrighty, here is our amine functional group. And if we look at we have the longest continuous carbon chain, 1, 2, 3, or 1, 2, 3. Because we have a tie, whether we number left to right or right to left, we are going to number right to left to give this methyl branch here the lowest possible number. There's also a methyl branch coming off of the nitrogen. So now we're ready to name N,2 dimethyl, and then we have a 5-carbon chain, so that would be the pent. Oh, but then we have to tell everybody where the amine is. I forgot that part, so we got to tell everybody 3-pentanamine, right? The 3 tells everybody where to find the amine along the 5-carbon chain. Alrighty, with our next example, here is our phenol. So we see that there is a branch. We have an ethyl branch. We are always going to give the carbon with the alcohol group the lowest possible number and number the ring to give the branch its lowest possible number. So this would be 3-ethyl, and we'll just say phenol. Okay, so with phenol it really encompasses the hydrocarbon skeleton and the functional group all in one name. Okay, last 2 examples. Here is our alcohol. So we're going to number the chain to give the alcohol the lowest possible number. That puts the branch at carbon 3. 3-methyl. And now we got to tell everybody where on the chain the alcohol is. 2. It's a 4-carbon chain. And then we put the suffix, -nol. So these are going together to tell everybody where to find the alcohol on the 4-carbon chain. And our last but not least, here is our functional group, an alcohol. In this case, we see 2 wedges. So this would be cis. All right. And here is our second branch, the propyl group. We're always going to number to give the functional group the lowest possible number. And then our secondary consideration is the branch, so we're going to number counterclockwise. So to name this last practice problem here, I'll put it kind of low so we can get the whole thing. There's the cis, and then we would have 3-ethyl. And we have our parent hydrocarbon, the root, cyclohex, and then it's an alcohol. And then, so that'd be hexanol. And so with rings, we know that this must be on carbon 1. If you put the 1, no problem. Alrighty, so this was a big tutorial, but we just covered the nomenclature of alcohols, amines, carboxylic acids, aldehydes, ketones, and amides. So now's a great time to get in and practice some more on your homework to reinforce your understanding.